Welcome to Chapter 10, the Cartesian Plane. The Cartesian plane, named after the French mathematician René Descartes, serves as a fundamental element in mathematics, particularly in geometry and algebra. It is a two-dimensional coordinate system that is primarily used to plot points, locate positions, and graph equations. The system is composed of two perpendicular number lines, the x-axis which runs horizontally and the y-axis which runs vertically. These axes intersect at a central point known as the origin. Each axis is typically labelled to indicate the nature of the values it represents. The x-axis accounts for horizontal values, while the y-axis accounts for vertical values. This organised structure allows for precise plotting and navigation across the plane, facilitating a clear visual representation of mathematical relationships. The origin is defined as the precise point where the horizontal and vertical axes intersect on the coordinate plane. Here, an ordered pair specifies the exact coordinates and location of any points situated on this plane. The x-coordinate indicates the horizontal position of a point, showing whether it is to the right or left of the central y-axis. Notably, in the context of an ordered pair, the x-coordinate is always presented first, followed by the y-coordinate, which details the vertical position relative to the x-axis. The y-coordinate, which indicates the vertical position relative to the x-axis, is crucial in understanding the layout of the coordinate system. The y-coordinate is always the second number in an ordered pair, which serves to pinpoint a specific location on a graph. For instance, consider the ordered pair p minus 3, 5. To locate this point on the coordinate plane, you would start at the origin, move 3 units to the left, and then proceed to move 5 units upward. The intersection of the x and y-axis divides the coordinate plane into 4 distinct quadrants, each representing a different range of values for x and y coordinates. In the Cartesian coordinate system, quadrant 1 is defined where both x and y coordinates are positive, making this quadrant a region of positive values. Moving counterclockwise, quadrant 2 is characterized by a negative x-coordinate and a positive y-coordinate, indicating a mix of positive and negative values. Quadrant 3 is unique as it includes both x and y coordinates in the negative, representing the lower left part of the plane. Finally, quadrant 4 features a positive x-coordinate and a negative y-coordinate, completing the cycle of the 4 quadrants with this mixed value orientation. The distance formula is a mathematical calculation used to determine the distance between 2 points on a coordinate plane. It relies on the Pythagorean theorem. When you have 2 points on a plane, x1, y1, and x2, y2, the distance separating them can be computed using the following equation. Distance equals sine x2, x1, 2 plus, y2, y1, 2. This formula determines the length of the line segment that links the 2 points. The midpoint formula is a tool in mathematics for determining the midpoint between 2 specified points on a coordinate plane. It is commonly utilized in the fields of geometry and algebra. When presented with 2 points on a plane, x1, y1, and x2, y2, you can compute the coordinates of the midpoint using the following formula. Midpoint equals sine x1 plus x2 to y1 plus y2, 2. This formula calculates the average of the x-coordinates and y-coordinates of the given points, leading to the coordinates of the midpoint.